Hello everyone, today we'll be looking at some quick solutions of All India Akash Test Series JEE Advanced 2019 Test 1A Paper 1 Code C and D. So let us start with the first section. This section contains 6 questions and the questions may have one or more than one option correct. Okay. So question number 19. 45 ml of given aqueous NaCl solution requires 30 ml of 1 molar AgNO3 for complete precipitation. From the following statements, select the correct ones. We have to assume that the molarity is equal to molality and the Kf and the Kb values for H2O are given to us. Okay. So let us first try and figure out the concentration of the NaCl solution. Students, we know that Ag plus ions will precipitate Cl minus ions from the solution. So the equivalents have to be equal. So 45 into m. Let's assume that the molarity of the NaCl solution is m. So 45 into m shall be equal to 30 into 1. So solving this, we can get the value of m equal to 2 by 3. Okay. So now it is told to us that the molarity value is equal to the molality value. So this shall be equal to small m as well. Now the examiner is interested in the values of the freezing point and the boiling point. Okay. So delta TF, it can be written as I into Kf into m, whereas delta Tb can be written as I into Kb into m. So students, the value of I for NaCl shall be equal to 2. The Kf value given to us is 1.86 and the molality value is 2 by 3. So this will give us a value of 2.48. Okay. And if we check the delta Tb value, so it shall be equal to I into Kb into m. The value of I is 2 again. The value of Kb given to us is 0.51. And the molality value is again 2 by 3. So this gives us a value of 0.68. So let us look at the options now. The depression in freezing point of the solution is 2.48. Yes, the statement is correct. The elevation in boiling point of NaCl solution is 1.68. Students, this statement is incorrect. It is 0.68. The molarity of NaCl solution is 0.67. This statement is correct. It came out to be equal to 2 by 3, which when converted into decimals, it converts into 0.67. Okay. The freezing point of the solution is minus 1.24 degrees C. This statement is also incorrect because it is minus 2.48 degrees C. So students, we have to mark option A and option C as the correct answer for question number 19. Let us look at the next question, question number 20. In a sample of unielectronic species, all the atoms ions in ground state absorbs n photons of equal energy and on de-excitation exactly n photons are emitted. Okay. Then the possible energy of the absorbed photon. So students, it is told to us that on de-excitation exactly n photons of same energy are emitted. So the photons of same energy will be only emitted in the case when the transition takes place from n equal to 2 to n equal to 1. Okay, there will be only one lambda in this case. So the examiner seems to be interested in knowing the energy difference between these two orbits for different isoelectronic species. So we know that delta E can be written as 13.6 into Z square 1 by N1 square minus 1 by N2 square. So this simplifies to give us a value of 10.2 into Z square. If we put the value of N1 and N2 as 2 and 1. So the answer which we are looking for when divided by 10.2 should be a perfect square. Okay. So 10.2 electron volts shall be correct. It gives us a value of Z equal to 1. So if we look at 40.8, this is also correct. It will give us a value of Z equal to 2. This when divided by 10.2 will not give us a perfect square. So this cannot be the answer. Option D is also correct. When divided by 10.2, it shall give us a value of equal to 9 and the value of Z shall be equal to 3. So students, the correct answer for this question are options A, B and D. Let us look at the next question. Question number 21. Consider the following hypothetical reaction: 5x2 plus 2y4 giving us 2xy2 plus 4x2y. So if at least 1 kg of each product is to be formed, then from the following, select the incorrect statements. Assume initially only reactants are present and the atomic mass of X is equal to 45 and the atomic mass of Y is equal to 40. So the examiner is interested in knowing the amounts of the reactants which we have to take if at least 1 kg of each product is to be formed. So if we look at the reaction stoichiometry now, 5x2 plus 2y4, they combine and give us 2xy2 plus 4x2y. So we have been given the molar masses of X and Y. So the molar mass of xy2 shall be equal to 125. The molar mass of x2y shall be equal to 130. The molar mass of y4 shall be equal to 160. And the molar mass of x2 shall be equal to 90. So students, we can see that for every 250 grams of xy2 produced, we have 520 grams of x2y which is formed. So obviously, if at least 1 kg each has to be formed, then the limiting case is xy2. So we have to form 1 kilogram of xy2 and x2y shall be formed accordingly. Okay. So the given mass which is required to be formed is 1000 gram, which corresponds to 8 moles of xy2. Now if there are 8 moles of xy2, then the moles of y4 required shall also be equal to 8. And the moles of x2 required shall be equal to 2.5 times this value. So the moles of x2 required will be equal to 5 by 2 into 8, which shall be equal to 20. So we can now figure out the masses of x2 and y4 required. So the molar mass of x2 was 90. So the grams required will be equal to 20 into 90, which gives us a value of 1800 grams. The value of grams of y4 required, it is equal to 160 into 8, which is equal to 1280 grams. Let us look at the options now. Option A. The minimum mass of reactant mixture taken for the above condition is 2.88 kilograms. Students, this statement is incorrect, as the total mass of the reaction mixture will be of sum of these values and it will give us a total value of 3080 grams. So the first statement is incorrect. Let us look at statement B. Mass of xy2 produced is less than mass of x2y produced. This statement is correct, students. We can see that for every 520 grams of x2y, the mass of xy2 formed is only 250 grams. So this statement is correct. Minimum mass of x2 required is 1.8 kilogram. The mass of x2 is 1.8 kilogram. This is also correct. The minimum mass of y4 required is 1.08. Students, this option is incorrect, as the minimum mass of y4 required is 1280 grams, which will give us a value of 1.28 kilograms. So since we have to mark the incorrect options for this question, so the answer will be option A and option D. Let us look at question number 22 now. An aqueous solution is prepared by dissolving sodium carbonate and sodium bicarbonate in water. So 20 ml of this solution requires 5 ml of 0.2 molar HCl solution to reach the end point using phenolphthalein as an indicator. In another experiment, 50 ml of the original solution requires 37.5 ml of the same HCl solution to reach end point when the indicator used is methyl orange. So we have to select the correct statement with respect to the original solution. So the examiner is interested in the molarity and the strength of the solution in terms of Na2CO3 and in terms of NaHCO3. So let us try and solve this question. So we had a 20 ml sample. We can assume that the millimoles of Na2CO3 be equal to X and the millimoles of NaHCO3 be equal to Y. So when the indicator used is phenolphthalein. It is given to us that the amount of HCl required is 5 ml of 0.2 molar. So MEQ shall be equal to 5 into 0.2. So this shall be equal to the MEQs of Na2CO3 divided by 2 only. As we know that phenolphthalein cannot indicate the neutralization of bicarbonate ions. So we have 2 into x upon 2. So on simplification, this will give us a value of x equal to 1. Now, students, it is given to us that 50 ml of the original sample was taken. So all the assumptions which we had made were done in 20 ml solution. So now we have to take this factor into account. So in methyl orange, we have 50 ml. So the moles or the millimoles, they shall be equal to 2.5 times the initial value. So millimoles of Na2CO3 is equal to 2.5x, and the millimoles of NaHCO3 shall be equal to 2.5 into y. So in presence of methyl orange, both carbonate as well as bicarbonate ion shall be neutralized. So we can say that the MEQs of HCl shall be equal to the MEQs of both the species present. Okay, so 2.5x into 2 plus 2.5y into 1, it shall be equal to 37.5 into 0.2, as the concentration of HCl used was 0.2 molar itself. Okay, so this on simplification will give us 5x plus 2.5y is equal to 7.5. So which on simplification will give us a value of y equal to 1. So students, we can see that the value of x was equal to 1 and the value of y is also equal to 1. So now let us look at the options. So we have to find out the molarity. So these many millimoles are present in 20 ml of solution. So molarity of both shall be equal. Na2CO3 shall be equal to molarity of NaHCO3, and it shall be equal to 1 upon 20, which gives us a value of 0.05. So students, the molarity of original solution with respect to sodium bicarbonate 0.05 m, it's correct. Molarity of original solution with respect to sodium carbonate is 0.1 molar, it is incorrect. 20 ml of the original solution contains 0.106 grams of Na2CO3. Students, it contains 1 millimole, and the weight of 1 millimole of Na2CO3 is 106 milligrams. So this statement is correct. So D option shall be automatically incorrect. So students, the option which we have to mark for this question are option A and option C. Students, let us look at question number 23 now. Consider the following order of dipole moments. So let us look at the first option now. We have pyrrole and then we have furan. So pyrrole has 1 lone pair of electron, whereas furan has 2 lone pairs of electrons. The dipole vectors in furan shall be opposing in nature, as there is a lone pair of electrons which is not delocalized. But in pyrrole, the lone pairs over nitrogen are delocalized. Okay, so this is going to have a greater dipole moment than this. So the first statement is incorrect. Let us look at option 2 now. We have CH3 and NO2 at ortho, meta and para respectively. So students, CH3 is electron donating, whereas NO2 is electron withdrawing. So we can see that in the third case, the dipoles shall be added, which will lead to a greater dipole moment of the para structure. So if we look at ortho and meta now, the ortho will have a lesser dipole, as the component of the vector created by NO2 will lead to some cancellation of vector created by CH3 molecule, whereas no such cancellation will take place in the meta molecule. Okay, so this statement is correct. Let us look at the third option now. We have been given bromobenzene and chlorobenzene. So students, this option is also correct, as the -I of Cl dominates in this case. So we can see that options 2 and option 3 are correct. So The answer which we have to mark for this question is option C. Let us look at the next question. Question number 24. So consider the following standard reduction potentials, E0 red. So we have been given 3 species and the reduction potential of each of them are given to us. So we have been given some statements regarding the species which are given in this E0 values. So looking at the reduction potential, students, we know that greater the value of the reduction potential, stronger is the oxidizing agent. So if we talk about E0 red, we can arrange this species as Y2 is greater than C plus is greater than X3 plus. This will be the oxidizing nature of the given species. Y2 is a stronger oxidizing agent than C plus, which is again a stronger oxidizing agent than X3 plus. Now if we look at the reducing capacities, so the reducing capacities will follow the reverse orders. The conjugate of these species will have an order opposite to this nature. So the least reducing shall be Y minus, followed by C and followed by X. So let us look at the options now. Y2 is the strongest oxidizing agent. The statement is correct. Amongst these species, Y2 is the strongest oxidizing agent. Let us look at the B option now. Y minus is a stronger reducing agent than X. This statement is incorrect. Y minus is not a stronger reducing agent than X. X is the strongest among these. Let us look at option C now. C is the weakest reducing agent. This is also incorrect. We had just seen that Y minus is the weakest reducing agent. Let us look at option D. C plus is a weaker oxidizing agent than X3 plus. Student, this option is also incorrect. So only statement A is correct and we have to mark incorrect statements for this question. So the correct answer for this question are option B, option C and option